Here's a nice example of testing you on buoyant forces and Archimedes' principle. And this is for kind of static fluids that you have. So let's take a look and dive into this one. Let's see if we can solve it. So an unknown object with dimensions of 25 inches by 45 inches by 20 inches, so it's kind of a rectangular prism that we have, has been partially submerged in mercury. Now, mercury is actually extremely dense. It's almost 14 times denser than water. So it's very difficult to try to submerge something in it. It's going to have quite a lot of buoyant force pushing it upwards. Now, if the buoyant force experienced by the object is 2,500 or 2,500 newtons, so that's a lot, right, of force, then what fraction of the object has been submerged? Now notice it actually says what fraction, so you haven't even submerged the whole thing. Now keep an answer, okay, as percent, you round it to the 10th, okay, so we'll do that. And then assume that 1 inch is 2.54 centimeters, and then the density of mercury is 13,600 kilograms per meters cubed. So that's going to be our assumption. So indeed, mercury is relatively dense. All right. Okay, so let's try to dive in. So what do we have given, okay, in here? So we have what the buoyant force is. So this is the buoyant force, and that buoyant force is 2,500 newtons, and of course it is upwards, right? So it's kind of preventing whatever this object might be from being pushed and submerged all the way in. Now, if you have this force, how are we going to proceed? Well, this is going to be the same thing as the weight of the fluid, so in this case of the mercury, so I'm going to put Hg for mercury. So that's going to be equal or equivalent to the weight of the mercury that has been displaced. So now, if you do that, so what is the weight of mercury? So please recall, so this is kind of the recall state, okay, if you wanted to find out. The weight of the mercury would have been the mass of the mercury multiplied by gravity, right? So that's what this would be. However, the mass of the mercury, because we are given the density here, so in order to do that, so we know what the density of mercury is, and that would have been the mass of mercury divided by whatever volume that it occupies, right? So in this case, whatever volume has been displaced there. So that's what we're looking for. So let me rearrange this. This is going to be mass of mercury is equal to just the density of mercury multiplied by volume displaced. And we're trying to find out what that volume is. Why? Because once we know the volume that has been displaced, then we can compare it to the entire object. And if they're asking us for what fraction of the object, well, then it's the volume submerged divided by the total volume of the object, and then we'll get a fraction or a percent, okay, of that particular object that is actually submerged. And you'll see probably it won't be much because of the enormous kind of strength and push of the buoyant force upwards of mercury. So let's take a look. So I'm going to just substitute everything back in. So the weight, okay, of mercury that has been displaced, so that's 2,500 newtons equals, and that is going to be equal to, so that's going to be the density. Now the density of mercury, so that's 1360. I'm going to start dropping, so this is in kilograms meters cubed, so we want everything to be in metric SI standards. So that's the density that I have, times whatever volume it is, and times gravity. Now gravity is 9.8, and then times the volume which we're trying to find. So I can certainly solve for volume. So this would have been 2,500 divided by, this is 13,600. This is times 9.8. So that's what I have right there. So let's see what that would give me. So 2,500 divided by 13600. So that's the first answer, and then divided by 9.8. All right, so That's the volume. So we have 0.0187575, etc. And this is going to be meters cubed, right? So this is all in metric standards. So now we know from that object, right, how much has been submerged, and it's this much. Now, the total volume, so V total of the object, okay, so here, well, we know, so this is 25, 45, 20. So this is 25 times 45 times 20. Now, the only thing is, this is in inches, so this is going to be inches cubed. So what would this be? Let's take that. So 25 times 45 times 20. So that is 22,500, but this is inches cubed. Now, we don't want inches cubed, right? So we want this back into, meters cubed, for instance. Well, to get from inches to meters, so what they gave us, 1 inch is 2.54 centimeters, right? So this is cubed. So if I'm going to do that, I'm going to take my answer, multiply it by 2.54, okay? And that would have been in centimeters. Now, if you want this in meters, right? So that means you can change this to 0.0, okay? And this is going to be, because you're going to switching it into meters, so that's 2 decimal places over. So 0.0254, right? So that's over, and that would have been in meters. So instead, because we want meters, I'm going to put 0.0254, and that's going to be cubed, all right? So what is that equal to? Well, there we have it, 0.3687, okay, etc., and that's meters cubed. This is the entire volume, but this right here, okay, is how much has actually been submerged. So now you have to take how much has been submerged divided by the total, which is what you see on the screen on the top right, and then you have your answer. All right, so I'm going to do that, okay, and let's see what it gives us. All right, so there you have it. Okay, so if you divide, you're going to get 0.05087, etc. Since they want it as a percent, well, then this is a percent, so you have to multiply it by 100. And it says round, so this is going to be 5.087%, rounded to the 10th, which is 5.1%. So it's only about 5%, okay, that you've submerged of this object, and yet you had so much buoyant force, which is present and pushing this thing upwards. So there you have it. So that's a nice example. It walks you through how you can utilize Archimedes' principle and the buoyant forces between, the buoyant forces equal to the weight of the fluid which has been displaced. So that's what we did here. And then we just solved for volume, so how much volume has been displaced, and then compared it to the total if we wanted the fraction. So imagine if we submerged the entire thing, right? That would have been a huge amount of force. All right, so thanks for watching. That's it for this example. Happy studying. Bye, everybody.